The inaugural attendance of an annual art festival is 80,000. The attendance Y increases by 6% each year. Part A. Write an exponential growth function that represents the attendance after t years. First write the exponential growth function, y equals a times the quantity 1 plus r to the tth power. Because the inaugural attendance of the festival is 80,000, the initial amount A equals 80,000. Because the attendance increases by 6% each year, the rate of growth R equals 600ths. Substituting 80,000 for A and 600ths for R gives y equals 80,000 times the quantity 1 plus 600ths to the tth power, which simplifies to 80,000 times 1 and 600ths to the tth power. So the festival attendance can be represented by y equals 80,000 times 1 and 600ths to the tth power. Part B. How many people will attend the festival in the 5th year? Round your answer to the nearest thousand. Notice that the value t equals 4 represents the 5th year, because t equals 0 represents the 1st year. First write the equation. Y equals 80,000 times 1 and 600ths to the tth power. Substitute 4 for t to get y equals 80,000 times 1 and 600ths to the 4th power, which is approximately 101,000. So about 101,000 people will attend the festival in the 5th year. Determine whether each table represents an exponential growth function, an exponential decay function, or neither. Part A. Notice that the x values increase by 1. Notice that the y values are multiplied by 1/2 to get the next y value. So as x increases by 1, y is multiplied by 1/2. Because x increases by a constant amount, and 1/2 is less than 1, the table represents an exponential decay function. Part B. Notice that the x values increase by 1. Notice that the y values are multiplied by 10 to get the next y value. So as x increases by 1, y is multiplied by 10. Because x increases by a constant amount and 10 is greater than 1, the table represents an exponential growth function. Determine whether each function represents exponential growth or exponential decay. Identify the percent rate of change. Part Part A. Y equals 4 times 1 and 900ths to the tth power. Notice that the function is of the form y equals a times the quantity 1 plus r to the tth power, where a equals 4 and the quantity 1 plus r equals 1 and 900ths. Because 1 and 900ths is greater than 1, the function represents exponential growth. Use the growth factor 1 plus r to find the rate of growth. First write an equation. 1 plus r equals 1 and 900ths. Solving for r gives r equals 900ths. So the function represents exponential growth, and the rate of growth is 9%. Part B. F of t equals 24 times 9300ths to the tth power. Notice that the function is of the form y equals a times the quantity 1 minus r to the tth power, where a equals 24 and the quantity 1 minus r equals 9300ths. Because 9300ths is less than 1, the function represents exponential decay. Use the decay factor 1 minus r to find the rate of decay. First write an equation. 1 minus r equals 9300ths. Solving for r gives r equals 700ths. So the function represents exponential decay, and the rate of decay is 7%. Rewrite each function to determine whether it represents exponential growth or exponential decay. Part A. Y equals 20 times 8100ths to the t divided by 2 power. First write the function. Y equals 20 times 8100ths to the t divided by 2 power. Next, use the power of a power property to rewrite the function as y equals 20 times 8100ths to the 1/2 power to the tth power. Then evaluate 8100ths to the 1/2 power to get y equals 20 times 9/10ths to the tth power. Because the decay factor 9/10ths is less than 1, the function represents exponential decay. Part B. F of t equals 2 and 5/10ths to the t minus 2 power. First write the function. F of t equals 2 and 5/10ths to the t minus 2 power. Next, use the quotient of powers property to rewrite the function as f of t equals 2 and 5/10ths to the tth power divided by 2 and 5/10ths to the second power. Next, evaluate 2 and 5/10ths to the second power and simplify to get f of t equals 1600ths times 2 and 5/10ths to the tth power. Because the growth factor 2 and 5/10ths is greater than 1, the function represents exponential growth. You You deposit $300 in a savings account that earns 3% annual interest compounded monthly. Write a function that represents the balance after t years. First, write the compound interest formula. Y equals p times the quantity 1 plus r divided by n to the n times tth power. Because you deposit $300, the principal p equals 300. Because the account earns 3% annual interest, the annual interest rate r equals 3/100ths. And because the interest is compounded monthly, n equals 12. Substituting these values into the equation gives y equals 300 times the quantity 1 plus 3/100ths divided by 12 to the 12 times tth power, which simplifies to y equals 300 times 1 and 25/10,000ths to the 12 tth power. The table shows the balance of a money market account over time. Part A. Write a function that represents the balance after t years. From the table, you know the initial balance is $300 and it increases 4% each year. So p equals 300 and r equals 4/100ths. Write the compound interest formula when n equals 1. Y equals p times the quantity 1 plus r to the tth power. Substituting 300 for p and 4/100ths for r gives y equals 300 times the quantity 1 plus 4/100ths to the tth power, which simplifies to y equals 300 times 1 and 4/100ths to the tth power. Part B. Graph the function from Part A and the function from Extra Example 5 in the same coordinate plane. Compare the account balances. The savings account in Extra Example 5 can be modeled by the function y equals 300 times 1 and 25/10,000ths to the 12th tth power. Graph each function. The money market account earns 4% interest each year, and the savings account from Extra Example 5 earns 3% interest each year. So the balance of the money market account increases faster. The value of a car is $15,000. It loses 10% of its value every year. Part A. Write a function that represents the value y in dollars of the car after t years. First, write the exponential decay function. Y equals a times the quantity 1 minus r to the tth power. Because the value of the car is $15,000, The initial amount A equals 15,000. Because it loses 10% of its value every year, the rate of decay R equals 1/10. Substituting these values into the equation gives y equals 15,000 times the quantity 1 minus 1/10 to the teeth power, which simplifies to y equals 15,000 times 9/10 to the teeth power. So the value of the car can be represented by y equals 15,000 times 9/10 to the teeth power. Part B. Find the approximate monthly percent decrease in value. Notice that in the function you wrote in Part A, t is time in years. So to find the monthly percent decrease in value, rewrite the function so it has an exponent of 12t, where t is time in months. Use the fact that t equals 1 divided by 12 times 12t and the properties of exponents to rewrite the function in a form that reveals the monthly rate of decay. First write the original function, y equals 15,000 times 9/10 to the teeth power. Then substitute 1/12 times 12t for t to get y equals 15,000 times 9/10 to the 1 divided by 12 times 12 teeth power. Using the power of a power property, the equation can be rewritten as y equals 15,000 times 9/10 to the 1/12 power to the 12th teeth power, which simplifies to y is approximately 15,000 times 991 thousandths to the 12th teeth power. Notice that the decay factor 1 minus r is approximately 991 thousandths. Solving for r gives r is approximately 9 thousandths. So the monthly percent decrease is about 9/10%. Part C. Graph the function from Part A. Use the graph to estimate the value of the car after 6 years. First graph the function, y equals 15,000 times 9/10 to the teeth power. From the graph, you can see that the y value is about 8,000 when t equals 6. So the value of the car is about $8,000 after 6 years.